Hello, dear student. I am Dr. Rohit Agrawal, Assistant Professor, Department of Physics, Sri RLD College of Science, Akola. Our topic is rotational motion. Rigid body. It is a solid body in which the particles are compactly arranged so that the interparticle distance or the distance between the two or more particles is small and fixed, and it is not disturbed by any external applied force is called rigid body. Such type of rigid body may have a linear motion or rotational motion or both the type of motion simultaneously. A linear motion is that in which all the particles like P1, P2, P3, P4 and so on up to Pn of a body moves along a parallel straight line. They covers a same distance in same time dt. So all these points have same linear velocity and it is given by v is equal to dx by dt. Rotational motion. A rotational motion is that in which the body rotates about a fixed axis such that all its constituent particles describe concentric circles about the axis. Consider a rigid body rotating about an axis at point O. At point O, the different particles like P1, P2, P3 up to so on Pn covers a distance P1, Q1, P2, Q2, P3, Q3 up to so on Pn, Qn in same time, so their linear velocities are different. But all the points rotate or turn through the same angle d theta in same time dt. So points have the same angular velocity and it's given by omega is equal to d theta by dt. Relation between linear velocity and angular velocity. Let r be the distance of the point P1 from center O. Then angle is equal to arc upon radius, and which is nothing but d theta is equal to P1 Q1. If you take r over here, then P1 Q1 is equal to r d theta. Then linear velocity of P1 will be given by v is equal to P1 Q1 upon dt. If we put the value of P1 Q1, that is r d theta over here, then we get r d theta upon dt. In this, when omega is equal to d theta by dt, then finally we will get v is equal to r omega. Angular momentum. Let a rigid body be rotating about an axis O with angular velocity omega. The particle at A of mass m1 is at a distance r1 from a point O having a linear velocity v1. So the linear momentum of the particle will be given by m1 v1 is equal to m1 r1 omega. The angular momentum of particle A about O is defined as the moment of its momentum about a point O. Then angular momentum or a particle A about O is m1 r1 omega into r1 is equal to m1 r1 square omega. Then the total momentum of rigid body about O is summation of m1 r1 square omega, which is equal to omega summation of m1 r1 square, and which is equal to I omega, where I is nothing but the moment of inertia. Rotational kinetic energy. The kinetic energy of particle A is given by 1 by 2 m1 v1 square. which is equal to 1 by 2 m r1 m1 r1 square omega square. The kinetic energy of the complete body is the sum of all the kinetic energies of the constituent particles. If suppose m1, m2, m3 up to so on mn are the masses of the particles at a distance r1, r2 up to so on rn from the point O, then here all the particles suppose possesses same angular velocity omega. Therefore, the kinetic energy of complete body is given by 1 by 2 m1 r1 square omega square plus 1 by 2 m2 r2 square omega square plus and so on, which is equal to 1 by 2 omega square in bracket summation of m r square, and which is nothing but 1 by 2 I omega square. So the rotational kinetic energy is simply the sum of linear kinetic energies of the particle of the body. Moment of inertia. According to Newton's second law of motion, every body continues in its state of rest or in uniform motion unless an external force is applied on it. It means that a body offers a property by means of which it opposes the changes of state of body. This property is known as inertia. The moment of inertia about an axis is defined as the sum of the product of mass and square of distance from the axis of rotation for each particle of the body. For example, consider a body made up of number of particles of mass m1, m2, m3 and so on situated at a distance r1, r2 and r3 respectively from the axis of rotation. Then the moment of inertia I of the body about an axis of rotation is equal to the sum of the quantities, that is m1 r1 square comma m2 r2 square and so on. Then I is equal to m1 r1 square plus m2 r2 square plus m3 r3 square plus and so on, which is nothing but I is equal to summation of m r square. The SI unit of moment of inertia is kg meter square and its dimension is m1 l2 t0. The moment of inertia is a scalar quantity because its value remains same if the direction of rotation about an axis is changed. A body is freely rotating about an axis opposes any change in state of rest or the uniform motion, then it means that the body possesses a rotational inertia. This property of the is expressed by saying that the body possesses rotational inertia of moment of inertia. Radius of gyration. The radius of gyration of a body about an axis of rotation is that the particular distance from the axis, the square of which on being multiplied by the total mass of the body gives the same moment of inertia of the body about that axis, and it is denoted by k. It is nothing but I is equal to mk square, which is equal to summation of mr square. It means that the radius of gyration is perpendicular distance between axis of rotation and the point at which whole mass of the body is supposed to be concentrated. Thank you.